Let's start with the basics. A scalar is a quantity that has only magnitude like mass, temperature, or speed. A vector is a quantity that has both magnitude and direction like velocity, force, or displacement. We represent a vector as an arrow. The length shows magnitude, and the arrowhead shows direction. Vector algebra, a complete visual guide. Today we cover vectors and scalars, addition of vectors, components in 2D and 3D and scalar and vector products. For class 11, 12, and G aspirants.
Wait, so speed is a scalar, but velocity is a vector? What's the difference exactly?
Great question. Speed tells you how fast, just a number, say 60 km per hour. Velocity tells you how fast and in which direction, 60 km per hour towards north. That direction component is what makes it a vector. Watch same speed, but different velocity vectors. Now let's see the types of vectors. A zero vector has magnitude 0 and arbitrary direction. A unit vector has magnitude exactly 1, written as a hat. Equal vectors have same magnitude and same direction. Negative of a vector has same magnitude but opposite direction. Collinear vectors act along the same or parallel lines. Coplanar vectors lie in the same plane.
How do we find a unit vector in any given direction?
Simple. Divide the vector by its magnitude. If vector A has magnitude bars a bars, then A hat equals vector A divided by bars a bars. This scales the vector to length 1 while keeping its direction. Watch the animation. Now, vector addition. There are two main rules. First, the triangle law plays vectors head to tail. The resultant goes from the tail of the first to the head of the second. Second, the parallelogram law plays both vectors at the same point and complete the parallelogram. The diagonal is the resultant.
But what if I have more than two vectors? Can I still use these rules?
Yes. For multiple vectors, extend the triangle law, it becomes the polygon law. Place all vectors head to tail one after another. The resultant goes from the start of the first to the end of the last. Watch how we add three vectors using the polygon law. Key properties of vector addition. Commutative, vector A plus vector B equals vector B plus vector A. Associative, A plus B plus C, grouping doesn't matter. Additive identity, adding 0 vector gives the same vector. Additive inverse, A plus negative A equals 0 vector. The magnitude of the resultant from the parallelogram law. If vectors A and B make angle theta between them, then the magnitude of A plus B equals square root of A squared plus B squared plus 2AB cos theta. This is a very important formula for G.
What happens when theta is 0 degrees or 180 degrees?
Excellent question. When theta is 0, vectors are in the same direction, and the magnitude becomes A plus B maximum value. When theta is 180 degrees, they are opposite, and magnitude is a minus B, which is the absolute value minimum value. So the resultant always lies between bars A minus B bars and A plus B. Watch the angle change. Components of a vector into D. Any vector in a plane can be written as a combination of two unit vectors, I hat along x and j hat along y. If vector A makes angle theta with the x-axis, then A equals a cos theta I hat plus a sin theta j hat. The x component is a cos theta, and the y component is a sin theta.
So if I know the components, can I find the magnitude and direction?
Absolutely. If vector A equals ax I hat plus ay j hat, then magnitude equals square root of ax squared plus ay squared. And the direction angle theta equals tan inverse of ay over ax. Watch, we break a vector into its components and reconstruct it. In 3D we add a third unit vector k hat along the z-axis. Any vector in space is written as A equals ax I hat plus ay j hat plus az k hat. The magnitude is square root of ax squared plus ay squared plus az squared. The direction cosines are cos alpha equals ax over bars a bars, cos beta equals ay over bars a bars, cos gamma equals az over bars a bars. And importantly, cos squared alpha plus cos squared beta plus cos squared gamma always equals 1.
What exactly are direction cosines? I always get confused.
Direction cosines are simply the cosines of the angles that the vector makes with each coordinate axis. Alpha is the angle with x-axis, beta with y-axis, gamma with z-axis. They tell you how the vector is oriented in 3D space. The key identity, the sum of their squares equals 1, is used in many G problems. Watch the 3D visualization. The scalar product, also called the dot product. Vector A dot vector B equals bars A bars times bars B bars times cos theta, where theta is the angle between them. The result is a scalar, not a vector. In component form, a dot B equals AX BX plus AY BY plus AZ BZ. Key property, if two vectors are perpendicular, their dot product is 0, because cos 90 is 0.
So the dot product can tell us if two vectors are perpendicular? That's useful. But what does the dot product physically mean?
The dot product gives the projection of one vector onto another, times the magnitude of the second. Physically, think of work. Force dot displacement equals the component of force along displacement times the distance. If force is perpendicular to displacement, no work is done, and that's exactly when the dot product is 0. Watch the projection animation. Important properties of dot product. Commutative, a dot B equals B dot A. Distributive, a dot B plus C equals a dot B plus a dot C. I hat equals 1, J hat dot J hat equals 1, K hat dot K hat equals 1. I hat dot J hat equals 0, and so on for all cross pairs. Also, a dot A equals bars A bars squared. This is very useful for finding magnitudes. Example, find the angle between vectors A equals to I hat plus 3 J hat minus K hat and B equals I hat minus J hat plus 2 K hat. Step 1, a dot B equals 2 times 1 plus 3 times negative 1 plus negative 1 times 2 equals to minus 3 minus 2 equals negative 3. Step 2, bars A bars equals square root of 4 plus 9 plus 1 equals square root of 14. Bars B bars equals square root of 1 plus 1 plus 4 equals square root of 6. Step 3, cos theta equals negative 3 over square root of 14 times square root of 6. Theta equals cos inverse of negative 3 over square root of 84. The vector product, also called the cross product. Vector A cross vector B equals bars A bars times bars B bars times sin theta times n hat, where n hat is the unit vector perpendicular to both A and B, determined by the right-hand rule. The result is a vector, not a scalar. Key property, if two vectors are parallel, their cross product is the 0 vector, because sin 0 is 0.
How do I remember the right-hand rule? And how do I calculate cross product using components?
For the right-hand rule, curl your fingers from vector A towards vector B. Your thumb points in the direction of a cross B. Watch the animation. For component form, use the determinant. A cross B equals the determinant of the matrix with I hat, J hat, K hat in the first row, AX, AY, AZ in the second row, and BX, BY, BZ in the third row. Expanding, I hat times AY BZ minus AZ BY, minus J hat times AX BZ minus AZ BX, plus K hat times AX BY minus AY BX. Properties of cross product. Anti-commutative, a cross B equals negative B cross A, not associative in general. Distributive, a cross B plus C equals a cross B plus a cross C. I hat cross J hat equals K hat, J hat cross K hat equals I hat, K hat cross I hat equals J hat. Cyclic order. I hat cross I hat equals 0 vector, and same for J hat and K hat. The magnitude bars across B bars gives the area of the parallelogram formed by A and B.
The cross product gives area? That's amazing. Can you show me an example?
Example, find a cross B for A equals to I hat plus 3 J hat plus K hat and B equals I hat minus J hat plus 2 K hat. Using the determinant method, I component, 3 times 2 minus 1 times negative 1 equals 6 plus 1 equals 7. J component, negative of 2 times 2 minus 1 times 1 equals negative of 4 minus 1 equals negative 3. K component, 2 times negative 1 minus 3 times 1 equals negative 2 minus 3 equals negative 5. So across B equals 7 I hat minus 3 J hat minus 5 K hat. The magnitude is square root of 49 plus 9 plus 25 equals square root of 83. This is the area of the parallelogram. G exam tips for vector algebra. Tip 1, for perpendicularity, set dot product equal to 0. Tip 2, for parallelism, set cross product equal to 0 vector, or check if ratios of components are equal. Tip 3, bars across B bars squared plus a dot B squared equals bars A bars squared times bars B bars squared. This Lagrange's identity is a powerful shortcut. Tip 4, unit vector along A plus B is useful in angle bisector problems. Tip 5, practice component form calculations. Most G problems use I hat, J hat, K hat notation. Like and subscribe for more math solutions at MAGPIEHUB.